In this lecture, we will be discussing all about SQL, or Structured Query Language. In this lecture, we will be discussing all about SQL, or Structured Query Language. The following is a summary of the SQL statements. We have data definition language, data manipulation language, transaction control, data retrieval, and data control language. SQL statements are free format, meaning we have the freedom to use spaces or indentations as we wish. However, we must use indentations for us to be able to enhance readability. And the end of every statement is indicated by a semicolon. The following are the common data types that we will be encountering when we deal with SQL. We have char for fixed length strings, varchar for variable length strings, number for numeric data, and then date, for date. So far, we have discussed everything that we need to do from business requirement up until modeling our data. Now, let's take a look at the Just Leave Books model and transform them into relational tables using SQL. The following is the schema for our Just Leave Books model. As we can see, we have the following tables: Customers table, Orders table, Order items, Books, Book author, Author, and Publisher. The attributes that are underlined are the primary keys for each of the table. And the attributes with the @ sign at the end are the foreign keys in our tables. In executing our SQL statements in this lecture, you may install the Oracle Express in your desktop if you want so, or you may opt to create an account in livesql.oracle.com. If you choose to use the LiveSQL account, this is how it's going to look like when you log in. For us to be able to run our statements, we will just go to SQL Worksheet and then type our commands in here. And then click on the Run. When we click Run, our output will appear in here. The SQL script for Just the Books model can be found under week 7 in Blackboard. To create tables in SQL, we use the Create Table clause, followed by the name of the table to be created and a list of the columns, their names, and the data types. In here, we can see an example of creating the table warehouse. Warehouse is the name of our table, and it has the following attributes, or columns: WHID and location. And right after our attribute names, we have the data types of our attributes. We have number for WHID and varchar12 for location. Now that we have created our tables, it is now time to insert data in our tables. To insert data, we use the keyword insert into, and then the name of our table, and then values, and inside the open and close parentheses are the respective values for each of our column names or attributes. You may also insert partial information into your tables. For example, if you only know the customer number, last name, and first name for your customers, you can specify those column names in your insert into statement. I would like to highlight something in this statement. If you have an apostrophe in your data, just use double apostrophe so that you will be able to insert that data. Take note that if you do not specify the values for the other columns, they will automatically be assigned the value of null. The following is the syntax to delete a record in our table. We start with the delete from keyword, the name of our table, the where clause, and then the condition that we need to satisfy. In this case, we are deleting all of the records in our warehouse table, wherein our record or our WHID is equal to 30. To delete an entire table, we use the drop table clause. Just take note that when a table is dropped, both the data inside the table and the structure of the table is deleted from our database. To fetch data from our tables, we use the basic select statement. We start with a keyword select, the names of the column that we would like to appear in our data, the keyword from, the name of our table, the keyword where, and the condition that we need to satisfy. Following are the capabilities of our select statements. We can either have projection, selection, joining of tables, the set operations union, intersect, minus, that we have discussed before require union compatibility. This is an example of a select statement that lists only the columns that are needed in our output. If we would like to include all of the columns, we can substitute the asterisk instead of specifying the column names one by one. If we would like to retrieve specific rows from our records of data, we use the where clause. In this example, if we would like to get the record of the customer with ID of 1007 and get the first name and last name, we specify it using the where clause. So we have select first name, last name from customer's table where customer number is equal to 1007. And as you can see at the very bottom, that is the result of our query. If we would like to change the name of the column in our output, we use column aliases. Take note when you use column aliases and we have blank spaces, we should enclose the alias in double quotation marks. It is also the case if it contains special symbols and if we want to retain the case. The following is an example of using column aliases. Instead of using the column name contact, we instead use the following column name, as we have seen in our output. Column aliases are commonly used with arithmetic operations. For example, if we would like to list the book title, the expected profit for books, with the expected profit smaller than $20, however, we know that we do not have a profit column in our list of columns. But we can get the profit by doing arithmetic operation between the retail and the cost. And we are showing it in our output as the column alias profit. To combine text data from one column with text data from other columns, we use the concatenation operator. For example, if we would like to list the names of customers from Florida, but we would like to combine the first name and last name into one column, we will do the following. So we have the select statement, first name, the concatenation operator, the following for the space, the concatenation operator again, and then the last name. And then our condition, the state should be in Florida. We can see the output from the right. To retrieve data from two tables, we would have to join them and use the common attributes, the primary key and the foreign key. For example, if we would like to get the title of the book alongside the name of the publisher, we would have to get the title from the books table and the name from the publisher table. As we can see from our from statement, we have the books, comma, the publisher, the two tables that we would like to join. And then in the where clause, we are having the equality sign for the common attributes. The books.pubid, the foreign key in the books table, and the publisher.pubid, the primary key in the publisher table. The result, as we can see, are the title and the name of the books. If we are retrieving data from two tables, and we have multiple conditions, we can do so using the following. For example, listing the number and the name of customer 1010 and his or her order number from the 3rd of April 2009. As we can see, we're getting data from the customers table and the orders table. And we are joining the two tables using the customer number in the customers table and the customer number in the orders table. Take note that in our select statement, we have to specify the name of the table if we would like to display it in our output. For any additional condition, we just use the AND operator. So to specify the customer number, we say AND customers.customer number is equal to 1010, and for the order date equals to April 3, 2009. And as we can see in our output, these are the orders of customer number 1010.